Hi guys, it's Mike here from Comp3 Interactive. Welcome back to the channel. So what am I teaching you today then? What I'm going to show you how to do is a very simple but very effective field of view. Now you can call it field of view, corner view, whatever you like. It's exactly the same. And what I'm going to be doing is using this red capsule as the enemy, the green capsule as the player, and we're also going to take into consideration obstacles such as walls. And we're also going to make a nifty little gizmo to show us exactly where our field of view is and the range. So if I just go ahead and play this, you'll see exactly what this does. Pop over to scene view, and as we can see, we have a yellow field of vision. So anything within that is what our enemy can see. And then the white ring is our range, so how far out our field of view stretches. Now currently, our enemy can't see our player because he's behind a wall. If we were to move that, we see we have this green line now, which always points at the player until we exit the field of view. Really cool. And the way this is set up, we're going to return a Boolean value whether or not we can see the player. And I'm going to leave that up to you as to what you do when you see the player. Be it the game's over or the enemy will chase the player, that's down to you. So I'm going to go ahead and I'm going to clear down the project of any scripts and we're going to build this from scratch. And I promise you it will not take long. But before we start, I just want to thank Gigatank3000 for sponsoring this video. I've got his links down in the description below. Go check him out on Twitter. Go check out his website. Keep up to date with everything that he's doing. And I also want to thank everybody supporting me over on Patreon. You guys are fantastic. That's Brandon Zill, Steve UK. Love you guys. Okay, so I've cleared down my scripts and a few other things that we'll get to later on in the tutorial. But first of all, we're going to create a C# script and we're going to call it field of view. What a surprise. Now we'll open it up in Visual Studio and we're going to need a few variables in here. We're going to need the actual radius in which our view can be seen, and we're also going to want the angle in which our view can be seen as well. So let's just go ahead and create some public floats. I'm going to call one radius and I'm going to call the other angle. We're also going to want to grab a reference to our player, or a reference to the object that you're trying to search for. So we'll just create a public game object and we'll call that player ref. Next, we're going to set up the infrastructure for dealing with the targets and the actual obstructions such as the walls. And we're going to do this using layers. So we can actually set up layer masks as a drop down inside of the inspector. So we can just toggle on and off which layers we want to be affected for certain things. Now that may be a little bit confusing, but you'll see exactly what that means later on in the tutorial. For now, all we're going to do, we're going to put in again 2 more public layer masks. And these are going to be our target mask. And we're going to need 1 more. And that's going to be our obstruction mask. Then the final variable that we need is the Boolean as to whether or not we can see the player. Okay, so we've got all our variables. Let's cache our player reference from the start. So we'll create our start method and we're just going to set player ref equal to game object dot find game object with tag, and we're going to search for the player tag. Simple as that. You must have done that before. Next, we're going to want to start looking for our player. And because this can actually get quite performance heavy, I'm going to do this inside of a coroutine with a delayed offset. So instead of doing all these calculations every frame, I'm going to make it so we only do it 5 times every second. The player will not notice that, but it just makes your game a little bit more performant, which we love. So let's start by creating this coroutine. So I'm going to create private IE numerator, and I'm just going to call this FOV routine. We'll declare our actual delay in here. So we'll just set delay equal to 0.2f. And then we're going to start an infinite loop. Now don't worry, we're inside of a coroutine. This will not crash your game if done correctly. So basically all we're going to do, we're going to start this coroutine and we don't want it to stop until the object is destroyed, or you could even have a variable to actually tell the engine that you do want to search or you don't want to search. Currently, we're just going to permanently search for the player. Next, we're going to need to set up a wait for seconds so we can actually delay our search by that amount of seconds. So we'll set wait for seconds, wait equals new wait for seconds, and we'll pass in our delay. Or you could even just pass in 0.2 there, and that's what we'll do. Now, in case you're not familiar with coroutines, wait for seconds will only work inside of a coroutine, and if you want a little bit more information on coroutines, I do plan on getting a tutorial out soon that covers them in a lot more detail, so make sure you subscribe for when that video comes out. So basically, we want to wait that amount of seconds before we check for the player. So we can yield return, and we'll just return the wait, which is 0.2 seconds. And then we'll actually do our searching. So we'll create a method called field of view check. And we also want to start that field of view routine inside of the start method. So we'll do start coroutine and pass in field of view. Perfect, so that's the basics done so far. Now we just need to actually check for the player. And we're going to use ray casting and sphere casting. So the first thing we'll do, we'll set up a collider array, because we don't care what type of collider we're going to find, we just know that it is going to be of type collider. And I'm just going to call this range checks, because this is going to be what's actually looking for our player. And we're going to set that equal to physics.overlap sphere, and then we need to set up all the parameters for this sphere. So first of all, it's the position, which is going to be our transform.position. So we're starting this sphere from the center position of our enemy. We're going to use a radius, because we need a radius. And then lastly, this is where we can use a layer mask. So put really simply, the layer mask, all it's going to do is going to look on that layer in particular to find these objects. So we're not going to be searching every single object in our scene, only objects that are on that specific layer mask. And the layer mask that we're going to be using is our target mask. And for this instance, the only object that's going to be on that target mask layer is our player. So now we've put our range checks out there. Let's have a look if we've found anything. So to do that, we'll check if our range checks.length is not equal to 0, so it's anything above 0, we've found something on that layer. So let's get the transform of that. So we'll cache a transform, we'll call that a target, and we'll set that equal to range check, and we'll get the first instance in that array, and then get its transform. Now the reason we're doing this is because overlap sphere returns an array, and we know that there's only our player on this layer. So we only ever want to get the first one. If you were looking for multiple objects, or there's going to be multiple objects in your target mask layer, then you just have to do a for loop over every one of your range checks. And then every one that it finds, if that's the one that you're interested in, then you'd continue with the rest of the logic that we're going to do in just a second. Next, we want to find the direction from where our enemy's looking to where our target is, our player is. And that's going to be in a vector 3. I'm going to call that direction to target. I'm going to set that equal to our target.position minus our current enemy's transform.position. And we're going to normalize that just to get the value between 0 and 1. Now that we've got that, we can actually start checking for the angle. So here we'll do if vector3.angle. So here we need our from position and our to position. So we're going to pass in transform.position, our enemy's current position, and then direction to target. And we're going to check if that angle returned is less than the view angle that we want divided by 2. Now we're going to divide it by 2, because if you think about it, if the enemy is facing forwards, you've got half of the angle to the left and half to the right. So we want to narrow that down by half so we can actually do a detailed angle check. So before we go into that, if this angle check fails, then the player is definitely not within our eyesight. So we can just set can see player to false there. That's all we need. But if the player is within the angle, then we want to make sure that our distance to our target is close enough to actually trigger that can see player. So we're going to set a float, and we're going to call this distance to target. And this one's really simple. It's just going to be vector3.distance. We're going to pass in our enemy's current transform.position and then our target's position. So far, we've managed to get the direction to the target, the angle in which we should be looking, and the distance that our target is away from our current view angle. So after all that, we can actually do the final ray cast, which is going to be the one that determines whether or not, yes, we can see the player, no, we can't. So if physics.raycast, we're going to start our ray again at our enemy's current position, so transform.position. Then we're going to pass in our direction to target, we're going to pass in our distance to target, and finally we want to pass in our obstruction mask. So we'll just break that down really quickly. We're going to start a raycast from the centre of our enemy. We're going to aim that raycast towards our player. We're going to limit that raycast to the distance that our target is away, and we're also going to stop the raycast if it hits anything in our obstruction mask. Now that's key for when we're dealing with the walls. And we've also got the exclamation mark right at the very start of this. Now the reason we've got that is because we want to do the positive check first. So this will mean if this fails, so if we're not hitting the obstruction mask, then we can see our player. So we can set can see player equal to true, or else can see player equals false. Tidy that up a bit, that looked messy. And then the one last thing we need to do, we need to make sure that if our range check fails, so our player isn't within range of the enemy at all, we'll just check if can see player was set to true, then can see player is false. And the reason we do that is if you were previously in the view of the enemy and you're no longer in view of the enemy, we want to make sure that we set can see player to false. So that should be our field of view script completed. If we select our enemy, throw the field of view script on here, we can see we have all of our variables. Now I'm just going to make this a little bit nicer. So I'm going to pop back over into my script and I'm going to add a few attributes up here. So the main one that I want is the angle can never go past 360 degrees. We know this. So we'll limit it to 360 degrees by putting a range attribute in there. If we save that and pop back, we should see our angle is now a slider. Perfect. But we're not actually getting any of this information on yet. Once we hook everything up, this would work, but we don't have any visual cue that this is working. So we're going to create an editor script that extends our field of view and it'll actually show us some gizmos on screen. Now, because this is an editor script, we need to put this in the editor folder. I've covered this in other tutorials before. The editor folder is a reserved folder that won't be compiled when you build your game, which is exactly what we need because we don't want this going into the final product. So I'm going to create a new C# script in there. And I'm going to call it Field of View Editor, just to keep everything nice and neat and tidy, keep all the naming conventions. So this is going to be a quick overview. If you do want an actual in-depth tutorial on creating your own editors, then let me know in the comments below, because I would love to do one of those, but it's whether or not that'd be useful for you guys. So we're going to blitz through this. There's a lot of maths involved. I'm crap at maths, and I've got all the values pre-worked out on my second monitor. So the first thing we want to do, we want to be using Unity Editor. Next, this isn't going to inherit from mono behavior. It's going to inherit from editor. And we also want to make this a custom editor for the type of field of view. So now whenever our field of view is active, this editor will start running. And we don't need start and update, but we do need on scene GUI. So the first thing we're going to do, we're going to set up a field of view object. We'll call that FOV, and we'll set that equal to the target of this editor. And we need to cast that to field of view. Next, we'll just do a little bit of styling. So we'll set the color of our handles, which are going to be the field of view arc and the radius as well. So first of all, we'll do the radius. So we'll set handles.color equal to color.white. And we'll draw in that radius. Now the way that we do that, we'll just again use handles.draw wire arc. And this takes in the parameters that you'd find on pretty much any sphere in Unity, which is going to be a field of view object dot transform dot position. We're going to give it a normal value of vector3 dot up. We're going to give it a from value of vector3 dot forward. We want this to be a full 360 degree angle. And then the radius we're going to put in as a field of view dot radius. So now if we were to play the game here, well, not play the game, we'll go into the scene view. We don't see anything yet, but that's because our radius is still set to 0. If we up that to 7, for example, we now have the radius in which our enemy can see our player. So we'll jump back and we'll start adding in the actual viewing angle. So here we're going to need to create two vector 3s, one for the leftmost side of the angle and one for the right side of the angle. But just to do that, I'm going to create a separate function just at the bottom here that's going to return a vector 3, and that's going to get the direction from angle. And this is where all that horrible maths came into play that took a while to figure out, but now it's all ready for you. So the first property that we need to pass in is the Euler Y value, and that's going to be the Euler Y value of our enemy. Next, we need another float, and that's going to be the angle in degrees. Now we want to add that Euler Y to our angles in degrees. So we'll do angle in degrees plus equal to our Euler Y. And then we'll return a new vector 3, which is mathf.sine. And into that, we're going to pass in our angle in degrees multiplied by mathf.deg to rad, degree to radius. Or radians, rather. Told you I hate maths. Next, we'll just pass in the y as 0, and then the z is going to be mathf.cos, and then in here we're going to pass in angle in degrees, again, times by mathf.deg to rad. So now that we can actually get the viewing angle from our direction, we can create two vector 3s, which is going to be vector 3 view angle 1. I'm going to set that equal to direction from angle. We'll pass in field of views transform dot Euler angles dot y negative FOV dot angle, because remember, if the enemy's facing perfectly straight, then we're going to want half of the viewing angle on the left and half on the right. So we'll pass in the negative angle, divide that by 2, and then we can just copy this for the right side of the angle. So we'll change that to view angle 2, direction from angle exactly the same, apart from we'll pass in the positive angle from our field of view object. Now we can actually draw those in as gizmos. So we'll change the color, we'll set handles.color equal to color.yellow this time, just so we can actually see him as a different object. We'll draw in our handles by doing draw line. And we want to draw this line from our field of views transform.position. So again, the center of our field of view object. And then we want to limit that by passing in, again, our field of views.transform.position. We're going to add in view angle 1. And then we're going to times it by our field of views radius. So that should limit that yellow line from going past our radius. And if we just copy and paste that again, we can draw in angle 2 for the right-hand side. So let's save that. We'll pop back over into Unity. We don't see anything other than a straight line, which obviously isn't right, and that's because we haven't set the angle in our field of view script. If we increase this, we get the corner view that our enemy can have. And you can set that to whatever you like. I'm just going to keep that at about 100. Finally, we want some indication of whether or not the enemy can see the player. And again, really simple to do. Inside of our on-scene GUI in our editor script, we can check if a field of view object can see the player, which we've set up inside here. That's our actual can see player in this function. Then again, we're going to change the color so we can see it a little bit more clearly. We'll set this to green this time, and we'll draw one more line. So that'll be handles.drawLine again from the center of our field of view object, and we're going to go towards our player reference that again we have in our field of view object. So that'll be fov.playerref.transform.position. Simple as that. Now the final thing that we need to do is set up our target masks. So if we come up here to the layer tab at the top, add a new layer, we're going to add in a target layer and an obstruction layer. So first of all, we'll set our player as the target, hop back over to our enemy object and set the target mask to be target. Next, we want our obstruction mask to be obstruction, and we'll go ahead and hit play and we'll see what happens.
Bruh.
Absolutely nothing. What have I done wrong? What have I done? That's it. When we're dealing with the angle, we shouldn't be using transform.position. We should be using transform.forward. It's all these transform.positions that got me messed up. Right, so now this should work. Let's go ahead and play. And there we go. We can see our green line that looks towards the player whenever they're in range, and only when we're within this viewing angle. But we can see that it still goes through the wall. And the way that we've set this up, it's going to be nice and simple how we do this. We select our wall, put it on the obstruction layer, and that's it. So now our enemy shouldn't be able to see the player through the wall. We don't have the green line, but we're definitely within range. We're in our angle. We come round and bang, there we go. Spotted him. And away. And, no, wait, no, I can't move the player around or else we can't see our field of view. But yeah, if we move that wall out of the way as well, we can see that we just have this perfect field of view. And what I'm going to do, I'm going to put this up on my GitHub page. I've been kind of neglecting the GitHub page recently. I keep forgetting to actually put the code up there that I write. But this, I think, is an extremely useful script. So if you want to download it, dissect it, change it a little bit, however you want, please feel free. I'll put the link down in the description below. But that's about all I've got for you today, so I'll see you again soon. Thanks for watching, guys. If you like the content, remember to subscribe to the channel for weekly Unity tutorials.